Yes, class. Am I audible to all of you? Austin, Faiza, Tarif, Shahid, Humam, Shavez. Fine. So in the last class, we had started with capacitance. Now, class, you had appeared for the test. Out of this, Shahid, you didn't give the test? The rest of you have appeared, Faiza and all. Yes, Shahid, why didn't you give the test?
I gave the test.
You're not audible, Shahid.
Ma'am, I gave the test.
You have given the test, subjective written test.
Yes, ma'am.
Okay, I'll check then once again because I didn't receive your sheet. Rest of the sheets I have received. Okay, Shahid, I'll check then. And rest of you, see, out of the questions which were given, I think only the last question that was given wrong because some other question I had given and the question was of capacitance and capacitance it was just started. So that wasn't even a part of your syllabus. So I have given you full marks in that capacitance question to all of you. But most of you have committed error in this derivation. Relation between electric field and potential. Didn't I tell you that this is a very important derivation? I think only Austin has done this derivation correctly and one or two. Most of you, why have you eliminated this charge? Work done, see in this derivation. In this derivation, your work done is equal to force into displacement, right? So force is given as QE, right? Charge into electric field and distance is dr. So this is one work done. And another work done that you obtain from the definition of potential, that is charge multiplied by potential. When you equate this with this, charge gets cancelled, then you get the value of electric field. Madiha, Faiza, Tarif, all you, I think only Tarif has done, Austin has done, and one or two. Rest of you have not done this derivation properly. And some of you have even not performed that equipotential. So the paper was very easy. I think 20 marks paper was it. And the paper was very easy in comparison to what type of questions, all the types of questions we had done in the class. So Austin, Madiha and Rabia, they could score above 15. Rest of you couldn't score above 15. Regarding that one MCQ which came, capacitance, I have given everyone full marks, whether your answer is right or wrong, though the answer was A option correctly. But I have given you full marks in that question. But apart from those questions, that capacitance question, rest of the questions were easy. That equipotential surface, that was a very easy question. You just had to write down the properties. Humam, you couldn't write the properties properly. Just two properties you have written. We have done so many properties. Try to write all of them because it was a 5 marks question. I hope the marks were mentioned in your question paper. Was it mentioned or not? Yes, no?
Yes.
Yes, sir.
It was mentioned. Fine. So please do have a look. If you all have that question paper, I think rest of you, especially students who are scoring less than 15 in this particular test, because the paper was very easy. The calculation part was very easy. -8 joules was the answer for that energy work done, which you had to solve. That was one question. These types of questions only were there, no, in your paper. First question was very easy. Most of you have done the first question properly, where I think 15 volt was the answer, something like this. So that also you people have attempted the first question properly, but most of you have committed error in the derivation, that relation between electric field and potential. Rest of the things you were able to manage. Faiza, check your calculations. Most of your marks have been lost in the calculations only. All right. And I wanted to ask one thing also to all of you. See, some of you couldn't complete the first lesson with me, right? Some of you had joined in the middle. I think Austin was there from the starting, Tarif was already there, and Humam was there, I think. Rest of you have joined in the middle of it. So just text me in the chat column. Just text a yes, those who want a class of the first chapter. Those who had joined in the middle and want a complete backup of first lesson, chapter 1. Because chapter 2, most of you are there. But for chapter 1, I do not remember who all have joined late. Because some of you were there, some weren't. So who all want backup of? Rabia wants. Anyone else apart from Rabia? Then I'll only take the class of Rabia. Nobody else needs the class of first lesson. Or some of you can take it as a revision class also. It's not necessary that it has to be a backup class or it has to be missed by you. If you think you want a revision so that you can at least perform well. Yes, I think, let me just check your scores. According to your score, no, I think you should just take the class and then again attempt one more test. That will help you. See, Austin has 20, Madiha has 17. So Austin has full marks. Rabia has 15. Till here, you 3 students could score above 15. Chavez has 14. Chavez also. Chavez, try to write down everything. All right, whenever you have a particular question, you skip things. Just write everything which is present. Right, just like in equipotential surface, also mention the definition and mention what are the things written. That in that question also you have lost marks. Rest calculation part is fine by you. All the calculations part you are writing well, but wherever the written part is there, no, you have to mention everything that is there in the questions. And especially that derivation, I don't know why you people couldn't do it. That is the most simplest derivation which we have, and it's one of the important derivations also. Faiza 13 and a half, Tarif 13 and Humam 12. So I think Faiza, Tarif and Humam, you all 3 should attempt that class. It would be just a revision class for you. All right, it would be just a revision class for you, because I want you all to at least have one more look of that lesson, first lesson. And regarding the second lesson also, I'll take the same class, because this is the chapter was of second chapter, no? So potential part was only included. So under that portion, I think that also I'll take. So till potential I'll take. All right, one class I'll take. It would be a revision class where students who have missed the portions, I think some of you had joined late, no? Chavez had joined late, Madiha.
Yes, sir.
Yes, right. So till potential, because see, capacitance already, all of you are here till capacitance. So I think I'll take one more class, but just tell me all those who are interested. According to all of you, one convenient time will be decided, because you have other subjects also, no? Other classes clash in the evening. So rest of the timings I want to decide. So these were your scores. I think Madiha has joined late. Madiha has scored 17. Same thing, Madiha, with you. You could have scored a full score. Just a thing with you, Madiha, is that the derivation part. A weekday, no, it is not necessary. It could be on a weekend also, as per your convenience, Austin. As per my free timing, where I do not have any other batch on that particular time, and when you all are free. Yes, Tarif, equipotential surface also, that would be discussed. Everything till potential. From the first lesson till potential, it would be discussed. So all those who have missed the portion, because potential part is missed, some portions initial, some people's initial portion has been missed. Yes, Madiha, this derivation. This derivation, what was the issue in this derivation? Why you people couldn't do it? You have scored 17 on 20. You could have easily scored a full score. I think 2 marks have been lost in this question, or 1 mark, and in some other questions calculation. Yes, Madiha.
Yes, ma'am. I couldn't remember during that time. Yeah.
And and all of you, just tell me, when are your summer vacations starting? In the chat column, please mention. Yes, Chavez. Just mention in the chat column, because then I'll remember it. Otherwise, when you will say, I'll forget. When your summer vacations are starting. 23rd June. Okay, Tarif. 25th June, 25th. Okay, around the end of June. So I think after one round of unit tests, your vacation will start. End of June. Fine. So you have 1 month of school, then June is off. All. So all of you are having vacations from 23rd June or 25th June only, end of June. Fine, fine. Because then we'll take some extra classes, no? Otherwise your syllabus will also lag behind. Like we are going a little slow with the syllabus. So in the summer vacation, we'll take extra classes and your syllabus will be on track. So do not worry about the syllabus, but whatever portions we have been doing, please try to be thorough with that. Like all the derivations and those portions I have been doing with you and have been repeating in the class, right? So that's why in this test was very simple. I had given all the very, very simple questions. Equipotential surfaces definition and all. Okay, Faiza, you had attempted in the way, but you had no, in that case also, the way you were doing it in the school, some of the portions you had missed. That's why you didn't lose all the marks in that question. It's not like you had obtained 0 on 3 marks question it was. The way you people write, see in the derivations portion, you have to mention this quantity. Let us assume this quantity is this, because at the end when you're mentioning V is equal to E something, EV, what is E? What is V? You know E is electric field, you know V is potential, right? You know these portions. But the examiner who is checking, this was a major problem with all of you. Nobody has written everything in detail. I think only Rabia had written everything in detail, that this is for this is for this. You have to mention the whole, when the derivation part is there, right? And questions like equipotential surfaces properties, electric field lines properties, these also you have to write whatever you know. Whether it's of 5 marks and you 7 points, then mention those 7 points, right? Because in equipotential, so these are very scoring questions. So Pfizer, you also you are writing anything, mention E is electric field, let us assume, or even you're suppose writing a question of a derivation of capacitance. In the last class we had seen so many derivations, and those derivations do come in your exam. Suppose a question comes, then you have to mention, you have to start the question like this: let us assume 2 parallel plate capacitors with the cross section area A and the distance between the plates as D, like this you have to mention. All right, in the class we don't do it in so much detail because it takes time. That's why I mentioned the letters. In your exam also, if suppose you do not have so much time, all right, if you do not have so much time with you and a whole derivation question is left, then you can do this thing. E, put an arrow, electric field. V, put an arrow, potential in this case. But if you have sufficient time, try to write everything in the all these written subjective questions. No, try to write everything which you know. All right, rest of the calculations portions you people knew it, but still I want a full revision class of before this capacitance part, because capacitance has been started and all of you are present. So only Shahid's paper I have received now. So I'll check your paper, Shahid. I don't know why I didn't receive yours. I thought you have not attempted the test. So I have now received yours. So I'll check it today and I'll tell you on Wednesday. And others, let me know when do you want the class. All of your weekdays are, I think, busy, no, in physics, in maths and bio also. Maths, biochemistry. So I think Saturday would be fine. Which day?
Yes, on Saturday.
Saturday, no? I think Saturday would be fine. Because Saturday from 6:30 here, you people have chemistry class. Class 12th is busy. So morning, Saturday morning is fine?
Yes, sir.
Saturday morning. All right.
Miss
Then on
Saturday when?
Wednesday, we'll discuss the timing. Yes, someone is saying something? Tarif?
Miss Saturday when I have special class on Saturday morning.
Timings can be changed then. Then Friday morning?
I have school on Friday.
Hmm?
I have school on Friday.
Acha, you have school on Friday. So Saturday, what is the timing, Tarif?
Miss.
Just let me know the timings. I'll
Yes,
shift it. We can have it here afternoon. And whenever you
this
prefer.
afternoon.
Just mention me the timings, Tarif. Just mention me the timings.
Yes, Miss Vansi.
Okay, just check your timing. You can text me in the chat column. Then we can arrange if everyone is available on that time, because all those who have missed their class, they'll get a backup, and all those who have attempted, it would be a revision class for you. And then one more test you will give where the whole electrostatics will be included, because otherwise if in this such simple papers, if you will not be able to score more than 15, 16, 17, then in difficult questions, what will happen, right? Okay, let's start with the class then. 4:30 IST. 4:30, no, before that we'll over it. 4:30 you'll be available, because 4:30 will be in the evening only. We'll have the class in the morning then. Not before 4:30 IST I'll have the class. We'll discuss the timings on Wednesday. Wednesday we have a class. So today is Monday. Okay? Wednesday ko discuss kar lenge. All right, so we had started with capacitance. Formula of capacitance is ratio of charge and potential. Capacitance for a sphere, for a conducting sphere, is 4 pi epsilon naught r. All right, this we had seen. And if Earth acts as a conducting sphere, the capacitance becomes 711 microfarad. So there were 3 types of capacitors, out of which you just have to remember about parallel plate capacitors in detail. Spherical capacitors we'll see. In today's class only I'll tell you spherical capacitors. Then principle of capacitors we had seen, and all these derivations. See, all these derivations involved one basic step. Find out the net electric field, put the value of sigma. What is sigma? Surface charge density, right? Charge per unit area. Then put the formula of electric field in V is equal to ED, and then take the ratio of capacitance as charge by potential. Charge gets cancelled and capacitance is left. And a little modification, slight modifications were made in each case. Someone is saying something? Yes, Chavez?
Yes, ma'am, I was having a doubt here, ma'am. Air is insulating medium.
Which case you're having doubt?
Air, ma'am, like between the plates, air is there. So is it an insulator?
This one?
Yes, ma'am. Like air is the medium, right?
Air is the medium. Yes. Air is the medium here.
So here in the requirement, it is written that we need a dielectric medium.
So air is an insulator only, no? Air is not a conductor of electricity. So dielectric medium, whenever you have in your knowledge, all those materials which are insulators, that only act as dielectric. So air is not a conductor. When we had taken a conducting slab, we specifically mentioned it that yes, we are taking a conducting slab right now in between, because when we in the requirement of capacitors between 2 parallel plates, obviously dielectric medium means insulator will be there. So when we were specially mentioning that air is conductor is inserted, so we mentioned that conducting slab is placed, right? So air is actually an insulating medium only. It's not a dielectric medium. We don't put it specifically as dielectric medium. Dielectric medium is in general, but it should be an insulating medium more than that. So in general, when you create a capacitor, if air is completely filled, your parallel plate capacitor will be constructed because it's insulator. We don't want the charges to keep on flowing all the time. Otherwise, before even we conduct it, before we construct the entire circuit, the charges will be discharged. Understood? So you can
there
put
should
air.
not be a conductor.
Yes. When you are specially putting a conductor, then mention that you are putting a conductor. Otherwise, air is also fine. Dielectric medium with a constant K. So I think this was here which we had stopped. If you completely fill it with air, because air is an insulator, epsilon naught A by D, all these 4 formulas you all should remember. Fine. Completely filled dielectric slab, K epsilon naught A by D. Partially filled dielectric slab, epsilon naught A by D minus T plus T by K. What is T here? T is the thickness of the slab. Fine, K is already the dielectric constant. And if suppose we inserted conductor, then epsilon naught A by D minus T. That's it. Now class, one more thing. If I want to find out what's the energy stored in it. Energy we had seen, electric potential energy was also there when charges had flown. So energy will be there in capacitor also. And how had we seen the potential? You all have attempted the test. So I think you all must have studied. whenever we calculate the potential energy, one quantity gets converted into potential energy, that is work done. So here also we'll focus on work done only. Your work done is an actual key element which helps you understand how to find out potential energy, because entire work done gets stored in the form of potential energy. So suppose this is a capacitor. Now do not see all these variables, just go step by step. It's a parallel plate capacitor. One plate is positively charged, another plate is negatively charged. Q, capital Q is the total charge on the capacitor. This capital Q is the total charge on capacitor, and this capital V, this is the potential on the capacitor. Again, when you will be writing the derivation, try to write this properly. Let us assume that two parallel plates capacitors are present with the plates having the total charges Q, like this. Mention all those storylines. If you have time, then if you do not, then mention it in this way. But do mention what are your variables. All right. Otherwise, in your board exams, you will lose marks. Now, entire work done will be converted into potential energy. Whatever work done will be done by the cell, because we'll connect the capacitor with the help of wires to a battery. Now, the cell will perform certain work done, where charges will move here and there. That you don't need to see right now. But what actually happens? Entire work done gets stored in the form of potential energy. Now, work done, whatever is the change in work done. This formula we had seen, charge multiplied by potential. And I hope by now all of you must be remembering it, Q into V, right? Now see class. Let us assume a very small portion. Yes?
Ma'am, your charges in the capacitor are stored as potential energy.
Your voice is coming very low. Can
Charges in the capacitor are stored as potential energy.
No, charges are not stored as potential energy. Basically, see, charges generate the potential energy. It's like somewhat you are correct, but see, when charges are present in your system, because of those charges only force will be exerted, right? In Coulomb's law, we study this fact only. And then when force will be exerted, work done will be required. And then when work done gets required, that entire work done gets stored in the form of potential energy. So yes, actually it's the charge only, which is the basic intrinsic quantity that helps build up your potential energy through forces. Because the first thing that charges do, generate force, generate electric field, right? When forces get generated, if a single charge is there, electric field gets generated, work done automatically comes in your system, and work is done. If work is done, because movement is occurring, charge will move, work done is done, right? So it gets stored in the form of potential energy. Now we have chosen a very small charge, let's say small q. Suppose a very small charge I have chosen, that is q, fine. And this is, I'm just writing it as V dash just to distinguish it from the total. This is a very small portion of charge and small portion of potential I have chosen. So if you look at this derivation, a very small amount of work done by this very small amount of charge will be dW is equal to dQ into V prime, where this was the formula, no? Work done is equal to charge. So work done is equal to charge multiplied by potential. Now see, how do you write the potential's value in terms of capacitance? We had seen the formula of capacitance as Q by V. So what will potential become? Charge by capacitance, right? So if we are taking this very small, V prime is the very small amount of charge. This I'll mention also. So that this doesn't becomes confusing. V prime is small amount of potential. This is very small amount of potential. So if it's a very small amount of potential, so put it in this, what will happen? dW becomes, charge becomes dQ. This, look here, dQ into V prime. I'm writing V prime first. What would be V prime? V prime is a very small amount of potential. So what was the small amount of charge that we had chosen? Q. Capacitance will be C no matter what, and then this dq. So to find out the total work done, total charge, because what will I do with this small amount of work done? We want to find out the entire work done, no? So what we'll do? We'll integrate it. Integrate it from 0 to total amount of charge, that is Q. Just this step you have to understand. Rest of the step is just your basics integration. Understand this. I'm repeating. See, work done is equal to charge multiplied by potential, right? So dW will be, what is your potential? Potential is charge divided by capacitance into dq. So this was for a very small amount of work done. What we have to find? We have to find out the entire work done that is being done by the cell. So to find out the entire, we'll integrate the entire charge. Minimum amount of charge can be 0. So we had chosen the lower limit as 0. And upper limit, that is the maximum value of the charge. What can be the maximum value of charge? It can be Q only, capital Q, right? Because capital Q is the total charge that is possible. That's why we are integrating it from 0 to capital Q. When you integrate the work done, you will get the total work done. dW integral will be total. Now Q dq. See, capacitance is also a constant. So I'll put capacitance here. Tell me class one thing. When we are integrating Q dq, what should be obtained? Q dq, the way we write no x dx. So this we had discussed in the starting only when we are discussing integration. Good, Shahid. Very good.
Q square.
Q square by 2. Right. See, others, listen, the way we write no x dx, when we integrate x dx, how do we write? The power is there, n, x to the power n plus 1. We divided by the same thing, n plus 1. Remember this we had discussed. X to the power n is there. So that becomes n plus 1 divided by n plus 1. Similarly, here you have Q dq. It's like x dx only. Q is to the power 1 is there because nothing is mentioned. So that becomes 1 plus 1 and that gets divided by 1 plus 1. And then your limits from 0 to capital Q. First tell me, is this step clear to all of you? Should I repeat? Is this clear?
Yes, ma'am.
Okay. So this is your simple integration. N plus 1 divided by n plus 1. So this is Q 1 plus 1 divided by 1 plus 1. Now you can write this as Q square because 1 plus 1 becomes 2. And here also you have 2. And this capacitance C is there. And whatever are your limits, 0 to capital Q. So how do we put in the limits? First, we write the, I'm taking 1 by 2C away so that I can put in the values. First, we put the upper limit first, right? So capital Q, and what is the power? 2 minus lower limit, 0 to the power 2. Fine. Now, what have we obtained? We have obtained Q square divided by 2C. It means this entire work done gets stored in the form of potential energy. So potential energy's formula, this is the final formula which we have to remember. These were the steps of derivation. Now do not forget the steps. Final formula also you should remember, energy portion will be used throughout, right? So the formula becomes half Q square by C. This is the formula of potential energy. Now one thing class, if suppose I have in my question, I have charge and I have capacitance and potential energy is asked. So I'll put the value of charge, I'll put the value of capacitance, I'll obtain potential energy. What if I have capacitance and I have potential? I do not have charge. So what will I do? So see, best thing is that substitute the value of charge. Charge is what? Q is equal to CV. Put it in here. Half instead of Q square put. So that becomes CV square because Q is CV divided by C. This becomes half into C square V square divided by C. C1, C gets cancelled. This becomes half CV square. Fine. So if capacitance and potential are given in your question and you want to find out the potential energy of the capacitor, use the formula half CV square where C and V are given. If charge and capacitance are given, use this. Suppose let's say charge and potential are given. Capacitance is not mentioned. Then out of these two, you'll not be able to use any. Right. So what you can do, put the value of capacitance as charge by potential here in this formula. So that becomes, this is half Q square. Now, instead of capacitance, I'll put charge by potential. Square and Q gets cancelled. The formula that is obtained, this is half Q into V. So you have total 3 formulas, right? If in your question you are asked to write about potential energy, you are asked to calculate potential energy where charge and capacitance are given, you use the formula half Q square by C. If in your exam, your formula is given where capacitance and potential is mentioned, both these are mentioned, use the formula half CV square. If charge and potential are mentioned, use the formula half QV. Now class, out of all these, what you can do, remember one formula. Just remember half Q square by C, or just remember half CV square. Any of these remember. Suppose if you forget, put in the value like this. What have I done? Have I done any other derivation? No, I've just substituted the value using the formula Q is equal to CV. Just keep on using this formula, whichever quantity you have to put it in this, cancel out, you will directly obtain all of this. Otherwise, you can remember all of this. Fine. So this derivation also comes in your exam because it's a very short derivation. In your 2 markers and 3 markers, this comes. Basically, you have to remember this step. If you remember this step, no class, the rest of the portion is just simple integration. Fine. Note it down. We'll see some questions from this. And wherever you are not able to understand, ask me, write in the chat column, unmute yourself and get your questions clarified. Shahid, you have attempted question 3 twice. Yes, Shahid. See, first question is right. Your derivation also, you have done it correctly. Question 3, 2 answers are there. Is it by mistake that you have sent or what?
Yes.
Please resend the PDF, right? Because both the answers are different.
Yeah, okay.
And you have not attempted the second part of it, the work, the entire work done. Otherwise, the paper is very good. Equipotential surfaces also you have mentioned in very detail. Calculations are also correct. You should have attempted the second part. The second part was not difficult. Everything I think got cancelled and your work done came out to be 0. The second part. Just resend the PDF, Shahid.
Yeah, okay.
And class, one more thing, if you have any difficulty in any particular question, out of all the questions that leave the MCQs in, because MCQs 1 or 2 questions were given wrongly, no? So apart from the MCQs, in all the theory questions, if you have any difficulty, like Tarif has mentioned that he has difficulty in equipotential surfaces. If any one particular question you want me to discuss, that also you text me in the next class, or if time is permitted today, we'll discuss it. Mention me in the chat column that this question number. I think all of you must be having it. And all those who have scored below 15, you have to rewrite your answers. All right. Rewrite your answers, send the PDF. At least you should be thorough with this amount of small question. Fine. Just send me the PDF. It's not necessary that you send me today, tomorrow, when you have time, but before the next test, you should be thorough with this question paper at least. Yes, Faiz. I'll share my number, and any difficulty you people have, you can text me on WhatsApp also. Let me share my number with you. Whichever doubts you have, you're solving from somewhere else, you can send me that also. Just add +91 for the Indian code. So if you have a particular doubt in one question also when you are solving, that also you can send. If you want to arrange a separate class for yourself, so that also you can send me on WhatsApp. Just write your name in the WhatsApp chat and then let me know.
Now here I'm having a doubt.
No, not necessary. If it's not a long question, see, if it's just a 3-marker question, 2 marks or 3 marks, then mention any of the one of these. If you even write till here, no, half q square by c, that is enough. Suppose just in case, if it's a long question, 5 marks, because no steps are there. So we sometimes have to expand. So if it's a 5-mark question, though it should never be given in 5 marks, but just in case if it is mentioned, then mention this. Because see, after this you will mention this, then again this will be mentioned. So amount of space will also be consumed and your answer will also look lengthy. So it would be a 5-marker question. But this would come usually for 3 marks, maximum for 3 marks or 2 marks. So half q square by 2c, this is also enough. Any one of these also you can mention. If you have sufficient time, you are left with time, then it's the best to mention this. Okay, but Tarif, it's not necessary. You can mention only one. Yes, Austin, I'll see the question.
Ma'am,
Yes.
and here we are calculating the potential energy means the work done by cell.
Yes. Potential energy or the work done by cell. Right. So
To
even in your
bring
question, if it is just no energy stored in the capacitor, because your work done gets stored in the form of potential energy. So in sometimes no in your questions it is asked, write the energy stored in a capacitor. That time also you have to mention the same thing.
it is the work done to bring the charge to the capacitor. All the charges to the
No,
capacitor.
it's actually the work done. No, the work done by the cell means to move these charges. Because right now we haven't seen the charging discharging of capacitors. So work done by the cell means work is done to move the charges in order to generate the electric field. Because in the last class, remember, we had seen electric field was generated between the capacitor plates in the derivations in every cases. So that work is done by the electric field to set up this by the charges to set up the electric field actually. All right, but again these are in very much details. There is charging of capacitor, there is discharging of capacitors, and all these portions are not now included in your syllabus. That's why I'm not discussing in detail, but briefly you can understand this, that this is the work done by the cell to move the charges in such a manner to generate electric field. Fine.
Yes, ma'am, thank you.
Pfizer, tell me the date as well, the particular date for the test. And chapter 1 and 2 both are included, or is it just till potential? Okay, means capacitance is also included. Fine. And date also. Just mention the date. Rabia, you also mentioned me the syllabus, whatever is your exact syllabus and exact date. All right, 6 June. Fine. Same thing, Rabia. Okay, Rabia, means one extra, that is current electricity is also coming. Fine. Regarding your date, please tell me the date as well, Rabia, because accordingly I'll take your extra class then of current electricity. 4th June you are having. Fine. Take. I'll let you know for the class, because for current electricity you will be needing class. Right, first 2 lessons you'll be able to do, but for current electricity. All right, I'll just let you know. Yes, class, this question. Now all of you have to respond in this class, in this question particularly, because this topic we had discussed in detail in the last class. And those who aren't able to, at least try to unmute yourself and answer, or keep on answering in the chat column. And if you will be silent, it would be your loss only, because once you discuss in the class and then you write the answer, you remember that question. Now the question says that a parallel plate capacitor with plate area 10 centimeter, means we have some data, area is given as 10 centimeters. Separation means separation between the plates. This separation, small d, this is given as 5 millimeters. And thickness, T that we write in the formula, thickness of the dielectric plate, means dielectric plate is inserted. This is 3 millimeters. And dielectric constant, K, is also mentioned to you as 2. You have to find out capacitance and charge stored and energy. So for capacitance, if you find out capacitance, the energy and charges calculations are not difficult. See, we had seen 4 cases. I'm giving you 4 options. Epsilon naught A by D. Second, C is equal to K epsilon naught A by D. Third option, C is equal to epsilon naught A by D plus T minus T by K. And fourth is epsilon naught A, C is equal to epsilon naught A, D minus T. All of you, each one of you, write me in the chat column 1, 2, 3, 4 out of all these, which formula should we use? Shahid has answered. Austin, Shahid 2, Austin 3, Tarif 3, Madiha 4, Humam 1, Shavez 2, Faiza 4, Rabia 4. All right. C class. A parallel plate capacitor with plate area. Area is given. Separation between the plate is given. So this is a case where the separation between the plates is given as, I think, 10 millimeters. No, 10 centimeters. Separation 5 millimeters. All right. Plate area is 10 centimeters square, and this is 5 millimeters. Madiha changed her answer from 4th to 3rd. So separation between the plates is 5th. Now Shahid is also saying 3rd. Now having dielectric plate of thickness 3 millimeters. So if the separation between plates is 5 millimeters and the dielectric slab is 3 millimeters, it means the slab is less thicker as compared to the separation between the plates. Chavez also 3. Should it be 3 or not, class? See, a plate has been inserted. Had it been 5 millimeter the thickness, it means it would have been entirely dielectric medium. See the difference. Those who are answering no second option. When it was second option, this is the formula K epsilon naught A by D. When between your parallel plates, the entire is filled with dielectric slab. But if the thickness of the dielectric slab is 3 millimeter, it means this is lesser than this. So it would be something like this, right? This would be something like this, where the thickness is 3 millimeters. This is the slab. Anyone else who wants to change the answer? Now see, dielectric constant K is given as 2. So it gets confusing whether you have to put a second option or not. See, when you had to put the fourth option, third option, 3 and all, just understand, now you are placing a slab in between. In the fourth case, there isn't any conductor placed. This is clearly written dielectric plate of thickness 3 millimeters, right? So you have to, you are inserting a plate. And how to identify that this is different from case 2? See, 1 is definitely not possible, all those who are saying 1, because dielectric is mentioned. As soon as the term dielectric is mentioned, this term gets lost. Fourth, conductor is not mentioned, dielectric plate is mentioned. So this is not possible. There can be a confusion between these two. Now, how to eliminate whether it's option 2 or option 3? If we use the option 2, it means dielectric slab is completely filled. If we use option 3, it means this is partially filled. How to identify whether it is partially filled or completely filled? Because separation between plates is 5 millimeters and thickness is less. It means this is partially filled. So now tell me, all of you, is it okay by all of you? Is it fine with all of you that we are using this formula? Or someone else is disagreeing, right? So C is equal to epsilon naught A by, now this is just a formula based question, epsilon naught A by D plus T minus T by K. Now area, what is the value of area that I should put? Yes, Homam.
Yes, ma'am.
What is the value of area that I should put?
10.
10 centimeter. Faiza and Homam, 10 centimeter square is firstly the unit. 2 is not coming because of the sheet. This is 10 centimeter square. So I should, yes, Homam.
Yes, ma'am.
10 centimeter, should I just put in this formula as 10 centimeter area?
No, epsilon naught is there, right?
Conversion, some conversion has to be made. Homam. Area is 10 centimeter square. Always write your answers is in SI unit. You cannot put this as 10 centimeter square. All right. All these, nothing is given in SI unit. 10 millimeters, 5 millimeters, these are mentioned. I am writing everything in here separately. Madiha, 10 into 10 to the power minus 4. Yes, Shayad. See here, all of you. We cannot put everything directly. 10 centimeter square is given. So this becomes 10 into 10 to the power minus 4, because 1 centimeter, we write it as no 10 to the power minus 2. If it is square, so 10 to the power minus 4 meter square. The separation between the plates, small d, this is given as 5 millimeters. Faiza, how do I convert it into the SI unit? Yes, Faiza. This is given the separation between the plates.
Five into 10 raised to minus 5.
5 into 10 to the power minus 3. This is millimeters. Faiza, is it clear? Conversion, it's clear or not? You're present or not, Faiza? You're not responding. Yes, 5 multiplied by 10 raised to the power minus. Okay, okay, Faisal. You can unmute yourself also. It's not necessary that you should type always. As per your convenience, try to unmute yourself and answer. All right, fine, good. And thickness of the slab, T is mentioned as 3 millimeters. So similarly, we'll convert this as 3 into 10 to the power minus 3 meters. Epsilon naught's value also, we remember this. So in the formula, C is equal to epsilon naught A by D plus T minus T by K. Epsilon naught becomes 8.85 into 10 to the power minus 12. Area is 10 into 10 to the power minus 4. D is 5 into 10 to the power minus 3. This is D. Plus T is 3 into 10 to the power minus 3. Minus T is 3 into 10 to the power minus 3. What was the dielectric constant? 2. Dielectric constant is given as 2. So divided by 2. So D plus T minus K. Fine. Then you can solve it, whatever answer you obtain in this particular. This is the answer of the first part. Now, second part, you can solve this later because time will be wasted on this. Second part is saying charge. Charge is simply Q is equal to CV, right? Charge is Q is equal to CV. Now potential is mentioned to you, 100 volt, right? So you can obtain the answer and put the value, multiply whatever answer you have obtained with 100. Lastly, also, the last part is saying, asking you the energy, use any formula. Now you know the charge, you know the capacitance, you know potential. Whichever formula you can use, half CV square, any formula you can use. Take the capacitance multiplied by 100 into 100 and into half. Any formula you can use because you know charge, you know potential, you know capacitance. Once you obtain capacitance multiplied by potential, potential is already known 100. You can multiply both these to obtain charge and then multiply any of these to obtain the energy. Main thing in this calculation part you will be able to handle because you can take 10 to the power minus 3 common from here. This becomes 5 plus 3 minus 1.5. You will be able to do. The calculation is not difficult. It's just that you should know which formula to use because entire question will go wrong if you use this formula or any else. Question you people have written? Should I directly show the solution?
Yes, ma'am.
Noted now. Yes, Tarif. After this, we'll do current electricity. After this, no, after some small topics are left in this capacitance part, then you have series and parallel connection. That is only left. After that, we'll start with current electricity. Madiha, you're also having your exams this Saturday.
Mom, from Sunday.
From Sunday. When is your physics exam exactly on?
Sunday.
Okay, it's on Sunday only. Fine, then I think we have to have a class of chapter 3, all those who are having their exams, just for the purpose of exam. Because I'll do everything in brief. In your regular batches, we'll do everything in detail. But at least for the portion of at least chapter 3, we have to do it on Friday. So all of you should be available on Friday. Fine? Madiha, Faiza, Rabia. I think 3
Yes, ma'am.
students have told me, right? So at least chapter 3. Faiza doesn't need chapter 3. Faiza, only 2 lessons are coming. And Faiza, in any ways, Saturday, I'll take all of yours class. So the important thing that will be discussed. Faiza, your syllabus is fine. Yes, Shavez.
For me also unit test 2 chapters are coming.
In your school, 2 lessons are coming. When is your exam, Shavez?
It's starting on 4th June.
4 June. Everybody is having their exam on starting from 4 June. So these are your half-yearly exams.
Yes, ma'am.
Okay. So if 1 and 2 are coming, then Shavez, that's not also a problem. Because on Saturday, we'll have the revision class. So that would be helpful for your unit tests also. That is also good. It would be a revision class for your unit tests also. But students who are having more than chapter 2, like 3 and 4, like Madiha is having 3 and 4, Rabia, I think you were having chapter 3, no? Rabia?
Yes, ma'am. 3 chapters.
3 chapters are coming. So Friday, Rabia, we'll have the class. Rabia and Madiha.
Okay, ma'am.
Just text me done once written till here. So that was all about parallel plate capacitors. Now, you just have to remember a very small derivation of spherical capacitors. Questions are also usually not asked from this. But just in case, if it comes in your exam, spherical capacitors, because that is there in your syllabus, so we should do that. Cylindrical capacitors we won't do, but that is for your entrance purposes. Those who are appearing, those who will appear for NEET and JEE, those who have to remember the formula for cylindrical capacitors. Otherwise, these are enough. Now see, I have taken concentric spheres, right? So potential difference between the spheres, one sphere is R1, another sphere is R2. You just have to remember this case only, because rest of the cases are in detail and that is not a part of your syllabus. Nobody is going to ask you. Just remember this. So where radius 2 is greater than radius 1 means the first sphere is inside the bigger sphere. So charge is plus q here and charge is minus q here. Why is charge minus q? This you should just understand, because we had seen in the initial methods of charging. Remember, we had seen induction methods of charging. One process was charging by induction. So where negative charges, so that occurs only here. Charges get induced because of the positive charges. The rest of the charges that get resided are negative. I hope you all remember methods of charging. We had seen induction, where I brought a glass rod to the neutral body and all one charges got attracted to one side and rest of it were left. So using that phenomena only, other charges negative. Now, when I talk about the potential difference, see, if this is a sphere, I'm just talking about the first sphere. This is the first sphere, this is the second sphere. Radius is R1, the charge is Q. Rabia, can you tell me the potential on this sphere now? Radius is R1, charge is plus Q, this sphere. Rabia? Yes, Rabia. You all have attempted the test. Potential, till potential, you all have at least revised it once.
KQ by R.
KQ by R, yes. KQ by R1, KQ by R1, right, Tari. You can't have, is my voice cracking? I hope rest of you are able to hear me.
Yes,
Rabi, I
ma'am.
think it must be internet issue. Just check it once. See, potential due to a point charge or a sphere, that remains same. This is K capital Q divided by R1. Now, same thing for the outermost sphere. What will be the charge? Shahid. Yes, Shahid, this is the second sphere.
AQ by R2.
KQ by R2. This. Good, Faiza. Minus, see, charge is negative and potential is a scalar quantity. Minus KQ by R. Right? Now, see, if I take KQ common, because that is common in both of these, I am left with 1 by R1 minus 1 by R2. Now, coming to the formula for capacitance. Yes, Faiza. What is the formula for capacitance in terms of charge and potential?
Q by V.
Q by V, perfect. This is Q divided by V. So Q divided by V, what is V? This entire portion, KQ by 1 by R1 minus 1 by R2. See, charge gets cancelled. This is just the derivation. Look here, this becomes, if we take the the LCM over here, this becomes R1, R2 minus R1. So R1 into R2 goes up. Your formula of capacitance for spherical, for spheres, this becomes R1, R2 divided by K, R2 minus R1, or you can write the entire value of K. See, K is the formula for K. Yes, what is the formula for K, Madiha?
Yes, ma'am.
What? How do we write K? 9 into 10 to the power 9, no? What else?
Yes. 1 by 4 epsilon naught.
1 by 4 pi epsilon naught. Very nice. 1 over 4 pi epsilon naught. So if K is in the denominator, 4 pi epsilon naught will go up. 4 pi epsilon naught R1 into R2 divided by R2 minus R. This is it which you have to remember. No need to practice so much questions. If a question will come, no, it will be very direct. Just put in the value of K here in the denominator. You can use this formula as well. R1 and R2 will be mentioned to you. Just mention this. It can happen derivation is asked just in case. That is enough. This is not, you have to do parallel plate capacitors in detail. Just quickly note it down. See, the next topic is, we are doing it in the form of question, but I am mentioning you this separately. This can come as a form of derivation also, that what is the force between the plates of capacitor. We are doing it as a form of question, calculate force between the plates of capacitor. So two plates I have taken, area of the plates is A, the surface charge density is sigma, separation between the plates is D. Electric field is capital E, one is plus Q minus, another one is minus Q. So if it comes as a derivation, what you have to do, I hope now all of you must be knowing it. You have to write it properly. Consider a parallel plate capacitor with the area, surface area as A, surface charge density as sigma, and the separation between the plates as D. Electric field will be sigma by 2 epsilon naught. Sigma also has a meaning. Humam, what is the meaning of sigma? Charge is given to you. This is the case I have discussed. If just on this parallel plate, I want to find out what is sigma, what will it be? Yes, Humam? Humam, try. I have discussed this so many times with all of you. Faiza and Austin have already answered in the chat column. Formula. I'm asking the formula. Yes, Madhya. Yes, Humam, you are not answering. I'm asking this question to you. See, surface charge density, whenever this is asked, rest of you are right. This is charge per unit area. Now, can you tell Humam, charge per unit area, how can I write charge per unit area? The formula is charge per unit area.
Q by A. Yeah.
Q by A, right. Now, I think you can recall, we have done this, Q by A. Revise continuous charge distribution. This as a separate topic we have done. Good. Now, put in the value of this in electric field. This becomes Q by A to epsilon naught, right? Q by A to epsilon naught, that is the electric field. Now, formula of force. Formula of force. Yes, Austin, can you tell me formula of force in terms of charge and electric field? In terms of electric field, one formula we have, Austin.
E by V. E by Q. E by Q.
Electric field?
By Q. E by Q.
E by Q.
No.
Not E by Q. Yes, Madhya, Q into E. Not divided. Fine, Austin?
Yes.
F is equal to QE. Now, in this formula, F is equal to QE. Charge we know. Charge is given as Q. And electric field also we know. So now we can substitute everything here. That becomes, all right, one thing we can do is, in this particular question, if we are saying electric field is due to this plus Q, then force will be generated on this minus Q. So what you can do, you can consider this Q as minus Q also, because this is force is being generated on the second charge, no, by the second plate, into what is electric field? Q divided by A to epsilon naught. So formula of force becomes minus Q square by 2A epsilon naught. This can come in the form of question also. This can come in the form of derivation also. Fine, note down this.
Can you once again explain how we took minus Q?
Minus Q as in, see, two plates are there. From one plate, force is exerted. Right, we are considering, no, let's say the force is being exerted on the, it can be plus Q also in your final answer. It's just that in this particular case I'm taking, suppose force is being generated on this charge. So an electric field is being generated by this plate. Force is generated by this plate. So force becomes F is equal to minus QE due to this plate. And what is electric field? Electric field we are considering that is getting generated due to this plate. That's why we have taken this as positive and this as negative. You can exclude that also, because this is subjective, no, in which case you are considering where the force is being exerted. So that you have to mention in your derivation. That's why we mention the things in derivation.
Yeah.
Sigma by epsilon naught. See, electric field due to single plate is sigma by 2 epsilon naught. If there are two plates, then sigma by epsilon 2 epsilon naught plus sigma by 2 epsilon naught becomes sigma by epsilon naught. So that is between both the plates. Right now we are considering just due to this one plate, no, particularly this one plates. That's why I have taken this formula. Otherwise, two wouldn't have been there. One last thing I want to discuss, because in the next class, we'll directly start with sharing of capacitors. Energy density between the plates is also asked. So again, we are doing it in the form of question, but this can come in the form of derivation also. Whenever density term is mentioned, energy density, in current electricity, we'll see current electricity as well. Just a second. Yes. So this can also come energy density. So energy density means energy per unit volume. So energy, you have calculated, energy is half Q square by C, and volume, C, area of the plate is A, thickness, that is separation, is D. How do we calculate the area? Thickness multiplied by the surface area, that is A into D. So put both the things in the formula of energy density. We represent this by this symbol, a U type symbol. This becomes Q square by 2C AD. Now, in this formula, see, C is equal to epsilon naught A by D. But if we take the capacitance between two parallel plates, this is the formula, right? So if you substitute this here, this becomes Q square by 2 epsilon naught A by D for capacitance, again area into D. Is anything getting cancelled? Yes, this is getting cancelled and area is getting squared. So we are left with Q square by 2 epsilon naught A square. Class, sigma was, remember, sigma was charge per unit area. Right now only Humam has answered Q by A. So sigma square becomes Q square by A square. So can I write this Q square by A square as sigma square? Right, it would be the same thing. I can mention it, Q square by A square. So formula, this becomes for U, the formula becomes sigma square by 2 epsilon. Now to get my final answer, if I multiply and divide it by the same quantity, that is epsilon naught, will there be any difference in the answer? No, if you multiply and divide it by the same quantity, the quantity remains the same. So why am I doing this? Because by this, I'll obtain sigma square by epsilon naught divided by 2 epsilon naught square. Again, class, the way Tharif, you were asking what was sigma by epsilon naught. So between both the plates, the net electric field becomes sigma by epsilon naught. So if electric field between both the plates is sigma by epsilon naught, electric field square will become sigma square by epsilon naught square. So means this term I can write it as electric field square, right? So your final answer, the energy density, this becomes half electric field square instead of sigma square by epsilon naught square into epsilon naught square. So energy density between the plates is directly proportional to your electric field. Sometimes this question is also mentioned. What is the relation? So you can mention, this shows that energy between the plates is directly proportional to electric field. Quickly note this down. And
This is potential energy per volume.
Potential energy, yes. Energy per unit volume, that is your potential energy per volume. Yes. So you can use any of these formula, but we have used this, so we are obtaining this answer. And ultimately, you'll obtain the same answer only, but try to start with this formula only. It would be very simple for you. Just mention everything. Just the steps remain. Keep on writing while I'm narrating. Please start writing because you have to appear for the assessment also. Energy, the value of energy, value of volume. Once you put the value of capacitance. Then sigma square will come where Q square by A square is present, and multiply and divided by epsilon naught. So you obtain sigma square by epsilon naught square. Instead of that, place electric field. So half E square by epsilon naught gets used. Similarly, you will see in chapter 4 also where magnetic energy density is used. This is electrical energy density. There magnetic energy density will also be used. So question is, calculate energy density between the plates of a capacitor. And we are referring to parallel plate capacitor only. Quickly noted. And keep on texting me done as you keep on writing. So I'll scroll accordingly.
Just scroll up. Yes, sir.
Yes, square of electric field, it is directly proportional to square of electric field only. It's just when you write it, that if your electric field is present, if your electric field is increasing, your potential and your electric field density will also increase. That is correct. This is proportional to square only. It's just that we are referring to the proportionalities, because epsilon naught is constant and half is constant. So if we go by the physical term, it's just electric field and density is left. You can directly mention it is proportional to square also. Because we are just referring to on which factors does your energy density depend on. Now, how does it depend? How much it depends? That is given by the square. And all of you, once you have written till here, electric field, just quickly text me done in the chat column, because your class assessment also has to be started. Others have completed apart from Austin and Faiza.
Yes, sir.